started. You know, there's a lot of hassle going through all this. I know a lot of hassle for you guys, writing up these things, handing them in, doing the computer printouts. Then I spend half my weekend, that's all I do is correct statistics assignments. There's a lot of hassle. I still think it's worth it because it's kind of the way you get in there and kind of, it sounds wrong, but you kind of get in there and get yourself dirty a little bit with statistics. You have to get in there and do it. And okay, I wanted to just make a little comment. This is one of the few times I didn't do all 62 of them at the same time. It simply takes too darn long to do them all at the same time. But I could tell you a couple things I was looking for, and I decided to just show you. Whenever I correct an assignment, I always do it first. Okay? So in other words, I make believe I'm a student and I do it. And then, after I got that all done, then I start correcting. Okay, now I don't expect you to have everything down I do. That is not why I do it. But I do it because I want to understand, number one, what were the problems you guys had to do? And number two, what were some of the things that I taught you that you had to use in order to do the, stuff like that. So anyway, if there were two things that I thought maybe we were I wish I'd have seen a little bit more of, I wanted you to either do them manually or on the computer, right? Well, there's a bunch of them that I just saw no evidence that you did it manually, and I saw no evidence you did it on the computer. By the evidence, I don't mean like I'm a detective. I just mean I should have, like on number one, I should have either seen something like this. This is called manual. Or I should have seen something like this. Or in some cases, both. Because I think the book said, now do it on the, now check it or something. Anyway. But sometimes all I saw was an answer. Okay, and I think some of you thought a calculator was somehow manual. That's not what I mean by manual. I mean, I don't care if you do this and then pull out your calculator and go ahead and do it. But to do it on your calculator and just put your calculator answer down, it seems it's like you're in limbo. You didn't do it manually? I don't know. Anyway, here's number one. I'll just show you what my, number two, there was really no calculation to do, but, I don't know, this one was, but again, some of you, skipped, you did this part, and there was none of this. I don't know, you just thought, well, I don't have to do the rest of that question, do I? I don't know whatever. Wish we could have been a little more complete. Here, number 5. I really never, if you do it manually, don't you have to write out the numbers? Sure do. I can't do this in my noggin, so I had to waste, I had to spend all that time getting them in order, and then I had to do my divisions, and so some evidence of work would have been nice. Yes, I did show you how to do this, but that was a possibility on the computer, but okay. So, I don't know, I just thought we were a little bit short on the work side. The only other thing that worried me about the assignment was we have a lot of people who still have problems with histograms. I saw many, 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 many bars. Okay? Somehow I missed the point. Somehow I didn't get through to some of you that a histogram is supposed to be somewhere between 5 and 10 bars. And I saw some that had 60. I was barred to death. So there's some of you who I don't think ever got the computer part of it, because I can tell you're just trying to grab for graphical things, maybe in Excel. So I'll be happy to show you, but we've gone through it about 4 or 5 times in class, so I probably would do it privately with you, and that's fine. If you come and see me after class or my office back there's a computer lab nearby, and I can easily show you. But some of you, we got to get that straight before the test. I don't know what else. Here is a shorter one. There wasn't a lot you could do work-wise there. It was kind of an opinion question. They said to you which one would be the median, which one would be the mean, and why. And here's my answer, my explanation. On 13, you were supposed to do something similar, but then you were supposed to prove it. And so that's why I did the computer thing on the side. It's another manual one. Yeah, histogram should look more like this. Another manual one. The IQR problem to find out if there were any outliers for the Cubs. 37 really, either some people skipped it or there was almost nothing done. I had some people who just wrote me a note. I did this on the computer. That was nice, but there was no answer to the question. Anyway, just be a little more complete, please. Show your work, okay? I figure if I got to do this much, you should have to do at least this much. I mean, I don't. Okay. Let's put that aside now. Now, on the other side of it, I can tell you this. When I did correct it, I wasn't distracted. I was off in a quiet room, and you try to do side by side. If you think maybe I graded it a little too harshly, or if you think I graded it too generously, haha, you can let me know, and I promise I will reconsider. I just don't want to get all 62 papers back saying, could you look at this again? I don't want to look at all of them, but if you think maybe this is a little bit, could you reconsider this? Or are you wondering? Yeah, you have to do that because in this case, I didn't really tell you a whole lot of specific stuff. Every once in a while, you notice I wrote a note by a problem. But most of the time, if I wrote you notes, I wrote them on the top, usually, kind of a general comment. I mean, if I'd have just done real carefully every problem, you'd have gotten this back sometime next semester, and that wouldn't have made sense. So, anyway. Okay, let's get back at Chapter 3. Oh, you should have gotten a grade report. It's still new, and I want to make sure I have all your email addresses right. I know I used the college ones that were, they're on my WLC, but still, every once in a while, there might be a slip up. So, if you didn't get something, or you got it and you can't read it, or some other technical difficulty, let me know so I can, because I really want you to get those so you know what's happening. Right now we only have what? 2 categories filled? We've had 1 quiz and we've had 1 assignment, so there's like 1 in each of those categories. Later we'll have the categories more full. Mm-hmm.
This isn't necessarily about the grade report thing, but when I watched the multimedia for the class,
yes.
When I watched the screen, it's like weird colors, and maybe it's just my computer.
Okay. Has anybody else seen weird colors? You're talking about the video?
Yeah, you can't like see exactly what you're doing because there's like blues and yellows and green, all these weird colors.
Let me ask this: has anybody else watched any of the movies? Okay, so it's not like when I show them in class, because when I show them in class, they're fine.
Yeah, it's not like that.
Anybody else done any video watching from the My WLC site? What? Yours are okay. Okay, so we at least have 1 other one. I think it might be some setting, or what player are you viewing them in? Is it? Yeah, that's what I've been viewing them in too. Is that what you? So it's not the player. Have you seen? Let me ask you this: have you watched any other videos on that computer? No problem. In Windows Media Player?
Yeah.
Weird.
Maybe it's just the internet. I don't know. Your audio and everything is fine. like the background moving of what it is, but like you can't see.
Well, if you can't see it, it's not very good. Nope. So only 2 people in this room have seen videos, and one's good and one's not. Okay. I'll try to figure out what's going on.
I'll try to.
What? Yeah. That would help if you did that, because that might help nail it down. We'll try to come to a solution. Yeah. Good. I need to know stuff like that. Anybody else? Video or technical quirks? Because I'm trying to remove problems. Let me ask you this: how many did you see more than one video? And was
Yeah,
that was a
maybe I'll try a different one. And
that was a consistent problem?
mm-hmm.
Okay. How many did you look at?
I only looked at half of one.
Just one.
I was trying to figure out how to do that.
So one of the videos you looked at. Okay. Well, can I ask you which video it was? Do you happen to remember?
Yeah, it was like chapter 2, day 2, or something like that.
Okay, I'll take a look at that. We won't do that right now. Thank you. Appreciate the feedback. Okay, last time we left off somewhere right in here. We had, not many slides ago, had talked about these a couple new, abbreviations. The mu and the sigma sometimes being used instead of x bar and s. And then we learned our standardization formula. And I believe we used that to do this example 3.3. And I think, was that the last one we did? We didn't do example 3.3? What?
We just stopped it.
Okay, so maybe we should just pick it up right here. Okay, thanks. I'm going to do a little erasing then, so that we can kind of do this together. That's not very efficient, so I'll do this. Okay, example 3.3. I guess we better take a look at it. And example 3.3 I see is at the bottom of page 65, top of page 66. Okay. The heights of young women are approximately normal. That's a big buzzword in this chapter. Normal means, we're on this curve. That's a normal distribution curve. With mu, the mean of the population, being 64 inches, and the standard deviation, sigma, 2.7. So you notice I always write that down as one of the, it's one of the first things you want to get down. What's the mean and what's the standard deviation? And that was handed to us. I'll tell you where I got the x from. As the problem goes on the top of the next page, it says, a woman's standardized height is the number of standard deviations by which her height differs from the mean of all young women. And here's where it says a woman 70 inches tall, for example. Okay, that's where I got my x. Okay, so all of those were given. How many standard deviations is she away from the mean? So the key formula here is one I believe I know I showed you on that previous slide, which looks like this. The score minus the mean divided by the standard deviation. And we're going to be, hammering and hammering and hammering and hammering on that formula in this chapter. We're going to be using it over and over. Okay, so in this case, our score, x, minus the mean, mu, divided by the standard deviation, which is sigma. We get on top a 6, on the bottom a 2.7, and then, let's just get an approximation for this. 6 divided by 2.7, So 2.2 repeating. 2.222 forever. Okay, now, before we go any further, let's take a look at our graph and let's plot a couple things. I guess I can get rid of this dot now. The mean is just literally handed to us, 64. So that's telling us this center bar in this picture is 64 inches. And what population of women they used, I don't know. But you obviously are going to pick a homogeneous group. You're not going to pick, for example, 3-year-olds along with 25-year-olds. Obviously, there must have been something similar about maybe it was adult women. I don't know, but you gotta use some sense there too. Now, where does the standard deviation come into play? Remember, each notch is a standard deviation. If you see this says the mean plus 1 standard deviation. What is that in this case? 64 plus 2.7? This would be 66.7. And then here's the standard deviation, the mean plus 2 standard deviations. So if you add another 2.7, what do you get? 69.4. And we won't do all of these, but this one is the mean minus 1 standard deviation. This time we have to subtract 2.7 from 64. So that'd be what, 61.3? Do you see where I'm getting those numbers from?
Where did the graph come from? Did you explain about the 68, 95, 90, 97 rule, but where did the actual curve come from in the 34.1%?
Okay. All normal curves will always have those percents in those categories that I talked last time.
Right.
So because they told us in the book that this was a normally distributed height thing, I knew I could use that same good old normal curve.
Right.
So I just slapped that on here.
Okay.
And in every normal curve, the mean is always in the center. And then one notch over, well, that's just a mean plus one of these. And then 2 notches over is the mean plus 2 of these. And so I'll be doing this over and over again. And then over here, this is just a mean minus one of those standard deviations. So that's why we're using this curve. And I'm not going to keep going, but we could keep going. Generally, go 3 out and 3 back. Okay, I'm trying to give you a feel for what this looks like. Now, where is our 70-inch woman? Well, she's obviously past 69.4, right? So she must be somewhere in here, right? Now, look at what we found out in standard deviations. We found out she is, by the way, the fact that this is positive tells me she's to the right of the mean. If this comes out to be negative, then it means you start here and you go this way. Well, the fact that it came out to 2.2 positive tells me, starting here, go 1, 2, and a little bit more past. So she's 70 inches. She's 2.2 standard deviations to the right of the mean. She's also getting into some fairly rare territory, isn't she? You notice how short the curve is out here? And in fact, you tell me, she's what? Past 2 standard deviations out. Within 1 either way is 68%. Within 2 standard deviations either way. So between here and here, 95% of all women are between. And she's outside of that. So if there's 95 in here, what does that leave? 5%, right? For both sides. But we're only on the top. What's half of 5%? 2.5. So she's in the top 2.5% of all women. She's pretty rare, that 70-incher. I mean, I'm talking locally just with this little weird problem. Okay. So you see how, now what's cool about standard deviations is they work no matter what the mean is. And so if you start thinking in standard deviations, you go, whoa, she's past 2. She's in pretty rare territory. And it gives you a feel for how unusual your data is. Well, the book had asked us to find this, how many standard deviations was she from the mean. We found out And good old standard score formula, which I should put a rectangle around, uh, just keeps coming up over and over in this chapter, is very important. You know, this one we're going to keep using over and over and over again. There's another part to this problem. It says, similarly, where is a woman who is 5 feet tall? Of course, 5 feet is 60 inches. So this time what they want us to do is find out what the standardized height is for a 60-inch woman. So once again, we use the formula in the box. We take her score, 60. We subtract the mean, which is 64. We divide it by the standard deviation, which is again given as 2.7. Notice this time we get a negative on the top, everybody. -4. And again, let's get a decimal approximation here. We got 4 divided by 2.7. 1.48. -1.48. So that means that she, this gal, is 1.48 standard deviations to the left of the mean. So starting here, 1 and about 1.5. She's right about in here. So here's our 70-inch woman. Here's our 60-inch woman. She's still within, she's not as rare. She's short, but she's not as rare as the 70-inch woman was, because she's still in what, the 95% territory overall? So you see how standard deviations give you a feel for where you are in your data. Okay, let's keep getting used to this. Let's go on to the next one I've got up here. Anybody have any questions on this one? It'll take a while to get used to this. So I have oh yeah, you got one.
They don't give you
The sigma?
yeah, what? Are they always gonna give you that?
Yeah, you can't do anything without that. So don't worry about it. These two things basically are going to be handed to you. In fact, they got to give you this too. Otherwise, if they don't say, hey, what's the standardized height for? And then they'll give you this is like the problem. And so, yeah, this is pretty much got to be given. There might be another one where they'll give you this, and they'll give you these two, and you have to find that one. There's like always 4 things. 1, 2, 3, 4. And they pretty much have to give you 3 of them. So later, they might give us different 3 and ask us to, we'll do that too, but we won't do that for a while. Yes? It's nice if you make a little sketch. And maybe at least get a few of these numbers up. Yeah, and then remember how I would say, her question was, should I draw these all the time? I would say the drawing really helps give you bearings, so I like that. And as you make your sketch, put a line right in the center for your mean, and then you remember how to find this point? Where it changes from curving down to curving up. It's got to be somewhere right about in there. And then you'll know where 1 is, and now just copy this length. There was another question.
How did you know how far over, like, this 70-inch woman, how did you know how far over she was to the right? Was that the 2.2?
Right.
Because isn't the 64 and the between...
Well, that helps too. I mean, the fact that it was 70 told me it was a little to the right of 69.4, right?
I'm just confused, like, because between the numbers it's 2.2, but then between the lines it's 2.2?
No, I'll show you that one more time. First of all, let me just say, how did we find the 70-inch woman? Actually, 2 ways. I knew it had to be just a hair to the right of 69.4. And by 2.2, here's what you do. You start on the center line and go 1, 2, and a little bit more.
But isn't it 2.2 between the 64 and 6.10? Is that what that is?
Between the 64? It's just 2.2 of these notches over. One notch, two notches, 0.2, a little bit more. That's all. Did that answer your question? Not quite, because I was a little bit, I didn't quite get what you were asking me.
Yeah. It's 2.2.
Her neighbor
Oh,
is,
it's the other thing. Okay, I get it.
thank you, you spotted what she was talking about, and I didn't, I appreciate that. Other questions? Okay, let's try to get used to this and go do another one. This is example 3.5 in your book. So turn ahead. It says using the standard normal table. Okay. Find the proportion of observations that are less than 2.2. Okay, well, this is the first time we're going to use the table. So in other words, look, we already have the standard score. Okay? What's the percent? Now, because it's right here, I'm going to just sketch it. Isn't this approximately 2.22? This is just an approximation here. Okay, and I told you it was 68, 95, 99.7, but we're not on a notch now. So now what do we do? You know, we're a little bit to the right of a notch. 68, 95. So, and the answer is, use a table to find the stuff in between. And the table is in your textbook. And I'm going to show you how to use it. It's right in the front cover. By the way, it's also on that funny looking colored sheet. This thing. You probably all also have this. But honestly, I prefer to use the cover. There's nothing wrong with this. It's just that, I don't know, the cover's in color, and it's nice and handy. It's on these two pages. This is the whole bit. You don't have to unfold it or anything. Now, the first thing you got to look at, this is very important. Do you notice there are pictures at the top? Excuse me. And can you tell which part of the graph in both pictures is highlighted? And the answer is, isn't it the part on the left? Okay, so this is a good reminder that the readings in the table are the area under the curve to the left of wherever your notch is. Okay, that's important. Later, so in other words, they're giving you the area under the curve that's less. When you want to find the area under the curve that's greater, all you got to do is take the answer from down here and subtract it from 100%. Okay, so I like this up here, and therefore, whenever I print this for like your tests or quizzes, I always print the picture right with it because it's a good reminder of what the table is telling you. Okay? All right, now, you notice how on the far left of both pages, there is a Z column. See that? And you'll notice over here, there's negative Z's. And on this page, all the Z's are positive. Okay, now we want to find a Z-score of 2.22. Actually, we want to find a Z-score of 2.22222222, but our table doesn't go quite that far. So find, first of all, 2.2. You should be around here. Right? Now, what are the columns? Well, the first column is 2.20, the second column is 2.21, the third column is 2.22. Do you see how that works? So in other words, the columns are your hundredths digit. Now what about past that? Well, we just don't worry about digits past the hundredths. So what do you get for a reading for 2.22? You get 0.9868? I'm reading mine upside down. Okay. That means, what percent of the people are to the left of that black notch up there? And the answer is 98.68%. So 98.68% of the population are to the left. So when you're not right on a notch, when you're on a notch, you can say, I can use 68, 95, 99.7. But what about when I'm not on a notch? You can use the table. So let me write this down. Now, did I answer the question? I got to make sure. What was the question? I lost it. There's another problem with paging around. Let's see. By the way, the book does a pretty nice job of explaining. It says how to find it, and it says you should have come up with 0.9868. Good, we did. Now, find the proportion of observations that are greater than a z-score of negative 0.67. Let me write that down. Z equals negative 0.67. What's the percent for that one? Well, we're going to have to use our table. First of all, did you notice it says greater? Uh-oh. The table only gives you less, so we're going to have to do that subtracting. So now, go to your table again. This is your first negative lookup. Go to your table, and this time look for a negative 0.67. Well, that means what? First column, you want negative 0.6, right? Everybody with me? Or you should be down about here. Negative 0.6, and then you're going to go over to which column? The seventh column, right? And what do you get? Negative 0.67. You get 0.2514. Okay, let's just write that down. Now remember, what's that a reading of? That's a reading of how many are, it's a percentage, and how many are to the left, always. But the problem asked us for how many are to the right. It said how many are greater. So we're going to have to subtract that from 100%. So, you know, you just got to do a little subtraction, and we can do that in our heads, right? It's going to be what? 74.86? 74.86%. So, once again, I love this reminder on top. This is a forever reminder that the table only gives you less than, left. And so watch always really carefully, excuse me, when you're doing a problem and it asks you to find greater, your head always has to say, oh yeah, I got to subtract this answer from 100%. I think you would agree it's kind of silly for them to print this table twice when all you got to do is watch for that. Okay, so they only printed the less than table, and you got to remember when to subtract. Okay, so the final answer for that second part of the problem is 74.86%. Does that agree with what the book says? Anybody?
Yeah.
Good. So let's go on to another one then. Okay, and I better do some erasing so we can start from scratch. Okay, example 3.7, page 70. What percent of 14-year-old boys have blood cholesterol between 170 and 240? This is our first between problem. Okay, so this is going to be a little more of a challenge. So we don't just want to know less or greater, we want to know between. Okay, and then you'll notice that, I guess, somewhere on the page they tell us all of this. On the previous page they tell us the mean and the standard deviation. So this is kind of a continuation, I'm sorry. if you look at the previous page under example 3.6, it tells you what the mean is. It says it's 170 milligrams, and the standard deviation is 30 milligrams per deciliter. So you notice I wrote down on top, mean 170, standard deviation 30. And our first, notice I have two numbers, two scores this time. We want to find between 170 and 240. So I just wrote x1 is 170, x2 is 240. Now we need a plan. So I'm going to insert a page here. I got to show you what we need to do here. Okay. So let me just copy the picture and let's go to a new page. Okay. Now, we want to go between two numbers. And just for right now, let's say we want to find, I don't even know where they are. Let's say one of them is here and the other one is here. Okay? It doesn't really matter. How could I find the area between those two bars? Well, remember, our table always gives us left, right? So if I went in the table and we had this answer here, it's going to give me all the area that's to the left of that bar, right? And then when I do the second one, isn't it going to give me all the area to the left of that one? And how could I use those two numbers to find just this? Couldn't I just take this guy and subtract this guy? Can you see that? Because if I subtract this from this, won't I get this? Cool. So all I got to do is take the guy on the right, do him first, and do the second guy who's on the left, and then just subtract my 2%. And I got it. Okay, so that's my plan of attack. So let's go back here. No, I went the wrong way. Okay, which one's on the right? Obviously the 240, right? So should we do that one first? So here we go. Let's find the standard score for 240. I should write the formula out since we're not that used to it yet. So the formula one more time is and in this case, it's 240 minus the mean divided by the standard deviation. And what is that on top? 70 over 30, which is 7/3, which is 2 1/3. So that's 2.3 repeating. Okay? Now, should we look it up? Let's go look in the table. What's the percent for a z-score of 2.33? You can just give it to me in decimal form. 2.33. Thank you. Let's just put that off to the side here. Okay, let's just come back. Now let's do our second score, 170. Once again, we're using our standard score formula. This time our score is, am I right about 170? Okay, well this is going to be pretty easy because what's 170? Isn't it right on the mean? And what's going to happen when you do the standard score? It's right on the 0 mark. So in other words, it's right on the mean. Well, what percent of the population is to the left of the mean? You don't even have to look at a table for that. It's got to be half. Yeah. Right? Because here's what the table's telling you. If you're right here, what percent of the population is over there? It's got to be 50%. Okay, so we don't even have to look that one up. I mean, you can go look it up if you want, but it's 0.5000. And now, remember our plan was to subtract the 2, and we should have the percent in between. And so the percent in between those two scores is 49.01%. Everybody in here knows how to convert a decimal to a percent, right? You just have to, move the decimal 2 places to the right? Okay. So this is your first tweener. If they ask you to find a percent of things between two, plan of attack. Find the percent for the bigger one, find the percent for the smaller one, subtract the two, and you'll have the part between. Okay? Anybody have a question? Looks like we can try going at one more today. Anybody? Here's a little different one. So, again, let me do a little bit of erasing. Yeah, kind of to Austin's question from earlier. Remember Austin said, hey, are they always going to give you this and that? Okay, here we have something a little different given. It says, what height are 60% of the men below? So in other words, they gave us the percent. In the past problems, that was the thing we were trying to find. Okay, but of course they have to tell you more than that. And if you look, they got it. I got to tell you the mean. I got to tell you the standard deviation. Okay, now I'll explain where I got this. This time, we're trying to find the score. This is the first time we've had one like this. Now, the key is 60%. Boy, where were the percents in the table? When you were looking at a table, where did we read the percents? Weren't they right in the body of the table? So if I want to go backwards, guess where I got to start? I got to look for something that's as close as possible to 60% in the inside of the table. So you do it with me now. Try finding a percent in the table that's really close to 60%. And tell me when you found it. Okay, we got 1, 2. Read backwards, and what do you get for z numbers? Now, I know you're probably saying, well, there's nothing exactly 60%. You're right. But isn't the closest one at 0.5987? What are the z numbers for that? If you go back to the left, isn't it 0.2, and then you're in the 5 column? So do you see where I got this from? Okay, cool. Now, let's take our famous formula and work on it, only this time we have different things. We know z, we don't know x. Okay, so in this formula, plug in z. We don't know x, we do know the mean, and we do know the standard deviation. Now we have to do a little bit of algebra, not a lot, but we got to solve for x. How do we do that? Well, we got to get x alone, right? What should we get rid of first on the x side? Shouldn't we get rid of that 2 that's in the denominator? And can't we get rid of it by multiplying both sides by 2? So won't this be 0.5 over here now? And then all I got to do is add 74 to both sides. Hey, we got it. So below what height are 60% of the men? The height of 74.5 inches. So here's our first problem where we kind of had to do it, I guess you could say a little bit in reverse. So let's just check out the question again. This one said, hey, I already know the percentage. Tell me what the height is, where 60% of them are less. Okay, well, it says below here, same thing. So what we had to do is go to the table and find as close as we could to 60%. We got our z-score, and we used our good old standardization formula. The difference was this was missing, this we knew. Little tiny bit of algebra. Hey, now I know which height. Okay, we're going to, obviously, we got a ways to go yet. You know, it wouldn't hurt even though I haven't, what is it, Monday? I mean, my guess is the assignment's probably going to be due on Friday, so if you want to, if you look on the My WLC site, you should see the assignment. It wouldn't hurt to get started, but obviously I need to show you a lot more examples yet. So guess what we're going to be doing on Wednesday and maybe Friday? More problems. Yep.